chaps. Today we're going to carry on with calculus, and we're going to start the second part of calculus, which is integration. Okay, calculus really is made out of derivative, differentiation, and the second bit, which is like twin brother, twin sister, whatever you want to call it, which is integration. So we're going to start with this part. Okay, so let's take a function. Okay, 3x to the power 5. Okay, now we've learned, we know how to easily find the derivative. Okay, if I find the derivative, f tan x, that's going to be 5 times 3, 15. X to the power 5 minus 1, power 4. So we've got, there is what we call, the word we use in maths is the operator. There's a certain operator. If I do dy to dx, if I do the derivative of this function, I get this function. Now, you came across that in maths a lot of the times. We often have one operator, one function, and then the opposites, okay? The inverse function, okay? So we can't really call that a function. This is more of an operator because it's not a function. I'm not going to get into the exact detail why, but it is definitely an operator. You operate it on a function and you get another function. So in the same way, we have like an inverse operator, what we call an antiderivative. So what I'm introducing now is the antiderivative. If this is the derivative, this is the antiderivative. In other words, it takes us from this 15x power 4, and it brings us back to the original function, okay? The symbol for that function is that, okay? That's the antiderivative, okay? We put that and a little dx there, okay? It will make sense, not straight away. It will make sense in a couple of lessons. For now, it's just a symbol, okay? So I will write that. If, for example, I have 15x to the power 4, and I do this operation onto it, we call it the antiderivative, then by definition, really, I should get back my original equation. And it's almost true, but not exactly. You'll see in a minute why, okay? But that's the idea, okay? So we do a derivative in from one function to the other. Antiderivative will bring us back to the original function. So let's try and find out what's the antiderivative of another function like, let's say, 4x to the power of, no, let's do it a little bit easier. It's not easier. 12x to the power of 3. Okay? And we always have to put that little dx there at the bottom. Okay? At the end. You'll see why that dx comes only next week. Okay? So what I have to do, I have to think about a function that if I will operate the derivative, if I find the derivative of that function, the answer is going to be 12x to the power of 3. Okay? So if I've got, I'm looking for a certain function, okay? That's the function I'm looking for. That if I find the derivative will be 12x to the power of 3. So let's try and think about it, okay? Well, what will be, let's start by saying, okay, it's going to be x to the power of something. What will be the power of that x? Well, if we do the derivative, it will go down to x power 3. So the derivative of the original function must have been x to the power 4, right? Once we do I'll write it down here first, okay? So it will be x to the power 4, okay? And once we do the derivative, the 4 will become 3. Now, what will also happen with that 4? That 4 will come here and be multiplied by that constant, and that will give you 12. So what should that constant be? Correct, it should be 3, isn't it? Okay, let's check that again. 4 times 3, okay, I'll just write it down a little bit further away. So that should be 4x to the power of 3. Why is that? Because, sorry. 3x to the power of 4. Now when I do the derivative, the 4 will become 3. The 4 will also multiply by that constant to give us 12. Okay, so the answer appears to be 3x to the power of 4. Is that right? Okay, so I'm just working reverse, really. But there is a little problem. Let's just say, okay, that I'm adding, let's say, to that function a certain number, let's say 2, plus 2, okay? And I want to find out the derivative. Okay, so I know that there's a rule that the derivative of function, which is made out of the sum of two functions, will be the sum of the derivative of each function. So the derivative of 3x power 4 is indeed 12x power 3. What's the derivative of 2? Just a constant number. The derivative is 0. So in other words, that derivative of this function, okay, of 3x power 4 plus 2 is also going to be 12x power 3. Okay? So that, the answer, the possible answer, the antiderivative of 12x power 3 could be plus 2. How do I know? Okay? Well, I don't know. Because actually, if I just added plus 2, I could have easily minus 5. Okay? If I have a minus 5 and I calculate the derivative of this, my derivative of minus 5 is still 0. So that could be minus 5. You see what I'm getting at? We have some kind of unknown. Okay? We have, or later on we can call it 1 degree of freedom. Okay? We can in fact add any kind of constants to it. Okay? Plus a c. Okay? I can add another 1,000 minus 25,362. Any kind of constant I'm adding to it. Okay? When I do the derivative, I will still get 12x power 3. So that's it, okay? Without any more information, I must add that constant, okay? Right, I'll pause here. Okay, so just before I do examples, okay? I think I just, like the book said here, I want to just give some idea of what these symbols mean. So I did already mention this little snaky thing. That's basically the symbol for antiderivative or integration. Okay, this here, okay, is the function that I'm going to apply that derivative, antiderivative. Okay, so whatever inside here is the function. This dx, okay, which will become a little bit more clear. I will give you more of a geometrical understanding of what this integration means. Right now, we just invented this tool. But this dx for now just means that we integrating the function with respect to x and not, for example, with respect to y. Now, to be honest with you, in high school, even in advanced program maths in high school, we're always going to have a function with one. That's actually not right. Okay, so already, I correct myself. Already next year, you will see that sometimes functions are made out of, or can depend on two variables, x of and y. Function with two variables. There's also function with 3. Okay? And we will work, I think, a little bit with them next year. So this just tells us we are applying this antiderivative with respect to the variable x. This year is all just one variable. Okay, let's do some examples. Okay, so integration, antiderivative is basically a bit of a brain work. You're just trying to find out the function where we came from. And when we do the derivative of that function, we get that. Okay, so I just always think about, okay, start with that, okay, the x. Okay, what should be the power of the x? And it's always going to be 1 above what you see inside the integral sign. So it will be x to the power 4. Then, in my mind, I say, okay, let's start do the derivative of that. So that's going to be 4 times x to the power 3. So I'm going to have 4 here. I don't have 4 here. I will have 4 there, right? If I do the derivative, 4 times x to the power 3. But I don't have 4, I've got 2. So what do I need to do that 2? I need to divide by 2. In other words, it's going to be x power 4 divided by 2. Now I multiply 4 divided by 2, I'll get 2. But I must always add that constant. I always have to have that constant, because that constant, okay, when I do the derivative of that, it will be 0. Always have the constant. Okay. Next thing. Now, when you've got x under in the denominator, I think it's best to rewrite the whole thing, but as a negative power. Okay. So don't mess around with x in the denominator. It's too difficult. You can, but I think it's more difficult. Just write it down like this. Now I'm going to say, okay, the antiderivative, the power of the x will be 1 above. Okay, will be 1 above. Minus 2, right? Minus 2 is 1 above minus 3. Then I say, okay, if I do the derivative of that, I'm going to have minus 2 times x to the power minus 3. I don't have minus 2. So I need to divide by minus 2. Okay? Dividing by minus 2. Now minus 2 divided by minus 2 will be 1. And obviously, I'm adding the c. Okay? Now I've got, I think at this point, I'm just going to write like a little rule. Okay? If I've got a certain function, a polynomial, okay, with a constant, ax to the power of n, dx. If if I do the integral of ax to the power of n, okay, what I'm going to have is x to the power of, what will be the power of the x? 1 above the n, so it will be n plus 1, okay? Because when I do the derivative, the n plus 1 minus 1 will be n, okay? I still want to have that a as the constant, but I also need to divide by n plus 1. Because when I do the derivative of this, the n plus 1 will be divided by n plus 1, giving us 1. And then you end up with the a. Okay? And then obviously, I need to add the constant. So this is, I guess, the formula that you're working with. Okay? Let's move on to this. Okay? Obviously, it should be dx. Okay? So what we're going to do, okay, we're going to write minus 3, and just like I did here, I recommend to turn that square root into a certain exponent. Okay, and you know, I'm pretty sure you guys know, that square root of x is x to the power of half. Okay, now when I look at that, I can now use this formula. Okay, I can say, okay, I'm going to leave that minus 3 here, because I want to end up with that minus 3. Okay, the power of the x should be 1 above half. In other words, 3 halves. Okay? And now, I know when I find the derivative of that, the 3 half will become half, but it's also going to multiply the whole x here. So I want to get rid of that 3 half and end up with just minus 3. So I'm going to divide by 3 halves. Okay? Plus c. Okay? But now I don't want to leave it like this. This is not nice. Okay? So I'm going to flip it. You know, guys, how to flip it. Okay, I'll write it down. So it'll be minus 3x to the power of 3 half divided by 3 and times by 2 plus a c. Okay? And we'll do one last little thing. We'll write it down here and running out of space here. Let's just write it down here. Okay? So 3 and 3 cancel out. So I'm going to have minus 2x to the power of 3 half plus c. Okay? Now, that is mathematically absolutely fine. I would recommend you leave it like that. Maybe they'll ask you to write in terms of squares and stuff like that. Then you can also write it as minus 2x cubed square root plus c. Right? That's the same thing as that. And you guys know why. Right, let's do this business. Okay, now here I don't have x. Okay, look at this. I don't have x. So what will be the derivative of that? Okay, now I can use the formula. Okay, I'll show you in a minute how. But I wouldn't remember that formula. I would just say, okay, I'm going to have the x, which is power. I'm looking for a function that if I find the derivative, the answer will just be 3. Well, that answer is just 3x. Isn't it? If I have 3x and I do the derivative of that, well, I will have just 3. Okay? And obviously, I need to add a c constant. Okay? Alright? You could use that formula and you say, right, if I don't have x, well, if I don't have x, that's kind of like, give it a little bit more space. Okay, just 3 is the same as 3 times x to the power of, no, actually, no, let's not get there. Let's not get there. That is not going to help. Okay? So, yeah, you just do that. Okay? And yeah, sorry, I can't do that. Sorry. Okay. So I'll write 3, and instead of, if I want to insist in writing in terms of x, then the power of the x must be 0, isn't it? Okay, it must be 0, because x power 0 is 1. Okay? But now, if the x power is 0 here, then the x, if this is 0, then this must be 0 plus 1. So it should be x to the power of 1, or just x. Okay? Either way, it works. Let's move on to some more complicated examples. Okay, so the next example, and I'll probably just do one of them, okay, is when I have a bunch of polynomials added together. How would I do, okay, this is all under the, I don't need to write brackets, but because of dx is over here, then I know that all that is under the integral sign. So I need to do the antiderivative of all that function. I think what you can kind of have a good intuitive feel that this is going to simply be the integral of x cubed plus the integral of 2x squared plus the integral of minus 1 dx. Okay? the integral of a sum of function will be equal to the sum of the integral of each one of these functions. Or, okay, it can be written like this. If I've got f of x plus g of x dx, if I have two functions or more, and I have to do the integral of each one of them, that's going to be simply the integral of f of x plus the integral of g of x. And I should put the dx's here, okay? It's the same thing that we had with derivatives, okay? We learned that the derivative of some function is the sum of the derivative of each function. It works exactly the same in integration, okay? There's a way of proving it, but we're not going to follow that, okay? So, what is the integral of x cubed? That's no problem. It's going to be x to the power 4, okay? 1 higher up, the exponent is 1 above, and then I need to divide by 4, okay? 4 divided by 4 is 1, and I end up with that, okay? Now, here, okay, this is a little bit interesting. Obviously, I need to add a c. Okay, I need to add a c. Plus, integral of x squared. Well, that's going to be x cubed, okay? Now, I want to end up with a 2 here, but I have to divide by 3, okay? So, 3 divided by 3 is 1, and I'll end up with a 2. And I need to add another constant. But it's not going to be the same constant. It could be another constant. So, we'll call that C1, and we'll call that C2. So, each one of these functions comes with their own baggage, okay, with their own constant. Okay, but we'll see in a second. Don't worry, it's not going to be that terrible. Okay, now I have a minus 1. It's worthwhile, I think I'll write it down. The integral of any constant, okay, the integral of any kind of constant, okay, minus 1, before we had 2, whatever, is simply cx plus d, okay? So it's that number times x, plus another constant. I'll call it d now, because, well, I use c, okay? So I'm not going to have plus c, okay? Alright, fine. You understand what I say? Let's just give it the letter a. Okay, so now the answer will be ax, and we call it c. C for us is a constant. It's just that. Okay, so what's the answer here? It's going to be minus x, in other words, minus x plus another constant. We'll call it c3. Now let's rewrite this whole function, okay? We're going to say, alright, x to the power 4 divided by 4. I'm going to put all the polynomial, the x's first. Plus 2x cubed divided by 3 minus x. And now I should be writing c1 plus c2 plus c3, right? Add these three constants. But we don't know what each one of these constants are. They can be anything. So, nothing, instead of writing plus c1 plus c2 plus c3, which I don't know what they are, I'm just going to add them together to one big constant. Because if I'm adding three numbers, three constants, I'm just getting a number, another constant. And I don't know what it is anyway. So, plus c. You understand what I'm saying? You don't really have to, for each one of these function, add their own constant. Because you don't know what they are anyway. Just slap another constant at the end of this. Does that make sense? Cool. Let's pause here. Okay. Right. So now I've got an integral of function of two functions that are multiplied by each other. Okay. So I've got, I think a common mistake. If I ask you to do that, some of you would say, okay, you're just going to do the integral of x cubed, time it by the integral of 2 minus x cubed. Okay, something like that. Right? So in other words, you would say that if I have fx times gx, okay, dx, okay, the integral of a multiplication, a product of two functions, then that should really be equal to the integral of fx times the integral of gx. Okay? And if you do that, sorry guys, you'll be wrong. Okay, we don't have that rule. That is not correct. Just like it wasn't right in the derivative. Okay? When we find a derivative of a product of two functions, I can't just find the derivative of each function and multiply it. We can't do it. We just can't do it. So that is no such rule, and we can't do that stuff. What I gotta do, just like I did in when I had a derivative, what I gotta do is turn this product into a sum. That's not a problem. Okay, so I'm just gonna multiply. I'm just gonna FOIL. Okay, I'm just gonna FOIL. So it's gonna be the integral of 2x cubed minus x to the power 6 dx. Okay, so you see I moved away from a product like factorized function, okay, something times something. I simplified it. And now it's a sum, and now I can use that rule. So that's going to be equal to the integral of, 2x cubed dx minus, the integral of x power 6 dx. Now, I want to just show you what I've done here. Initially, I really should have said plus and put the minus 1 here. Okay? And maybe in this case, maybe you should still do that. But what is, okay, let's just do that. Let's just keep it simple. Some other time I'll make it easier for you. Let's just leave it like that, okay? It would work either way, but I don't want to get into that why. Okay, so what's the integral of 2x cubed? Well, that's going to be x to the power 4, okay? And then I need to have that 2 here, so we'll end up there. But I also need to divide by 4, okay? So when that 4 goes out, it will be divided by 4, and I end up with a 2, okay? I can write a constant, but we don't have to because we can add both constants into another constant at the end. So I'm not going to write that constant right now, and I'll do this. Okay, so this is x power 6, so it will be x to the power 7. I need to have minus 1 here, okay, and then divide by 7, so that will cancel that 7. Okay, right, now check out, I might as well just do it now. You see, I told you initially I could just take that minus 1, that constant out. Okay, put that minus 1 there. And ultimately, I did it, isn't it? Look, that minus 1 here, now it's going to turn this into minus. So you can get that minus 1 out. But you don't have to right now, okay? And now I need to add a constant, which is made out of those two constants. Okay? And then just simplify a little bit, 2 and 4, so it will be x to the power 4 divided by 2, plus minus 1 is basically minus x to the power 7 divided by 6. Okay? Pretty easy, isn't it? Let's write one last example. Okay, the last example is instead of function divided by a function, I've got a function, instead of function times another function, I've got a function divided by a function. And again, I can't find the derivative of that and divide by the derivative of that, just like I can't do with the multiplication. I need to turn this function into something plus something. So we're going to write it like this, okay? What I will do two things at the same time, okay? I will divide this by that, so I'm basically splitting this fraction, okay, into that divided by that, plus that, or minus that divided by that. But at the same time, instead of square root x, I'll write x to the power half. So I'm going to write 5x squared divided x power half dx. Okay, or let's leave that dx for now, minus 4 divided by x to the power of half, all of this dx. Okay, I don't really have to have that brackets here, but it's just to show you. Now I can split that into the two integrals. So that's going to be equal to the integral, and at the same time, let's write down 5x squared divided by x power of half. The answer is going to be 5x to the power 3 half, right? 2 minus half is 3 halves. Okay, dx. Okay. If you don't mind, I'm going to write minus the integral of 4. Okay. Instead of writing 4 divided by x power half, I'm going to write 4x to the power minus half dx, right? If half is in the denominator, then it's going to be power minus half. Okay? So I could have written plus minus 4. I could have done, and I'm happy with you doing it, but you can see that minus eventually, effectively, you can just get it out there. Okay? Just simplifying things a little bit. Okay? So, what is that going to be? Well, it's going to be x to the power of, what is 1 above 3 halves? Is 5 halves. Okay? Now, I want to have a 5 here, and I want to divide by 5 half there. So, when that 5 half goes there, cancel out with that 5 half, we end up with a 5. Minus, okay, 1 above minus half is going to be x to the power of half, isn't it? Okay, half minus 1 is minus half. Okay, I'll divide it by half, and I want to end up with a 4. Okay, see, if I had plus minus 4, then I'm just going to write plus minus 4. It's exactly the same thing, isn't it? You see what I'm saying? Okay, so it's easy to write down a minus there. Get that minus there. Okay, cool. Right, let's write, and obviously a constant. Okay, constant. Okay, and now I need to just flip that. If you don't mind, I'll do it like in one go. So the 5 stays down, the 2 goes up. When the 5 stays down, it will cancel the 5 there. So I'm going to have 2x to the power of 5 halves. and 5 and 5 will cancel, okay, minus, okay, timing, dividing by half is like timing by 2, so it's going to be minus 8x to the power of half. And obviously a plus a constant. And you can leave it like that, or you can turn that to square root x, and this is going to be x to the power of 5 square root, something like that. Right, that was a long video. Now you can do exercise 1.1. See you in the next lesson.